Welcome back to another devlog. This is number 31. So I spent 2 days just working on the sidewall dead zone functionality, and so after a lot of testing, I found that adding a 90-degree plane adjacent to the sidewall collider is a lot better at detecting um, than a diagonal taper. So you can see I have the generated mesh from the wall, and then getting a 90-degree plane to that the camera can detect and collide to. It was really an arduous task trying to figure out how to get the proper Z placement of this plane. I was really struggling until I just said, like, screw it. I'm going to take these wall prefabs and pretty much set the pivot point manually to a place that I can assume. Because when I was constructing this wall, the pivot would be in random places, like just for ease of movement, it would be over here or down here. So it's like when it was calculating its Z placement for the plane, it would just put it in like random places, and I could not get an easy algorithm to easily place the actual correct Z position for each different piece of wall. It was just totally unmanageable. But once I set the pivot for the wall, then the algorithm could be simplified and place it in the correct position. So here we have our dead wall solution, and I had to go and rework the camera configuration because it's slightly different for the 2D mode versus the VR mode. Depending, so in the 2D, depending on if you're in VR and 2D, it'll actually set a different configuration for the height. And I had to really test with the different heights of the ceiling what looks good on both modes. So pretty much the 2 days were filled with endless testing and refining and bug fixes. Unfortunately, the complexity of the system began to kind of spiral with cases, and I was forced to employ like a complex state machine to control the cases. There's just so many of these cases where, testing it, if you go in at a certain angle or you go in and out, does it behave properly? Does it get stuck? Does it, does the camera get confused and start jittering, back and forth? A lot of these edge cases, I got it. So it was kind of turning into like the head tracking functionality, where it's like you get it to a place where it's stable, but it's not 100%. I was finding, an unreproducible issue. If I go in a certain spot, it would misbehave. But the problem is there's no out-of-the-box solution for this. I couldn't really follow a tutorial and say, how do I do an interior dead zone functionality that's industry tested, and follow that. Or there's no third-party package to be like, oh yeah, here's a system where you can do this sort of functionality that's kind of tried, tested, and you could use this instead of. So I was kind of forced to invent the wheel in order to do this. And so I was thinking about doing like a cinema, because Cinemachine 2D has like a confiner that kind of does it for 2D environments, but it also has a 3D thing. But there's little support on YouTube or any, to actually do that. Plus, I would have to integrate it into my Invector camera system or scrap the Invector camera system altogether, which is not ideal because it's integrated into the whole character movement. So, so even after 2 days, I got it to a point where it's, I had trouble breaking it, but I'm still testing it now. I'm still kind of not happy with its performance. It kind of, it's not really like a smooth, you can see like it does multiple steps. It kind of feels jittery a little bit when it moves at multiple steps. The real complexity comes in when you move to the doorway. There were some cases where I had to leave a gap because what would happen when the camera zooms in for a lower ceiling height, it would actually cycle. It would move lower and then hit the edge collider and move back and then keep going around. And so I eventually solved that by moving the collider, the ceiling collider, a little bit further out so the cycle doesn't happen. But it happens in multiple stages, so it functions, but it's not clean, it's not simple, it's not smooth. So, and there's still some like unreproducible edge cases where, so it needs, it probably needs more work to really nail it, but I got into this point where, yes, I can have this system where it doesn't allow you to move to the camera doesn't allow you to move to the edge of the wall, and that solves a bunch of problems with being able to being able to view past the edge of the maze, especially when there was a gap here. You could still see, look at it, yeah, see, unreproducible, that camera jitter. So it's definitely not a system that I can ship to production right now, but I'll have to either scrap it or figure something else out. But right now, like, it sort of holds together, but it's not something that's like super quality right now. That I'm not 100% happy with. So So on Wednesday, I was finally able to get it stable. And then I was able to solve the case where you could there was a gap in here, but you could actually see over the edge of the maze. So that works now. But so this edge, it solves some problems, but it doesn't solve really all problems. The main problem was this other case where, especially in VR, where you're going to the corner here, in the very corner, and so that shouldn't happen either. You shouldn't be able to go to the edge here and it slips over the collider. But in VR, you could actually see beyond, like sort of like this. In VR, you'd be able to see something like this. You'd be able to see the room beyond, and then more above the maze. I didn't want that to happen. So how do I solve that case? Because the edge collider dead zone system doesn't really solve that case. So I was doing some brainstorming how to solve this. And I was thinking, what if we had like a something that fades the objects that are very far in the distance. It fades to black, right? I was thinking of maybe we put like a plane here that has a shader that kind of acts like a filter, that objects closer would be more visible, and then objects in the background kind of fade off into the distance. But that really didn't seem like it was possible to do with shaders, really. Um, so, and then one solution was to actually modify and actually place for each of these materials a shader that would detect the camera distance and fade out automatically. But that means I'd have to make sure every shader in my level is capable of that. That means modifying the out-of-the-box material with a shader that doesn't fade from the camera. So that's not really feasible either. Um, so um, so another idea I played with was adding this front wall here, confiner dead zones, kind of like how I did with the side, but add it to the back wall as well. So it's like the camera can't move past. And that's kind of, you know, that kind of goes back to the, you know, it'll allow it to go outside the box, but it's kind of it's kind of moving back to the making the camera be confined to inside the scene box. Even if it's like pseudo, like it can still go outside, but not too far, so you can't really see above and beyond the mage. Plus the other problem with that, like I'd have to integrate what I've done here with the side walls into the back wall as well, and adding that sort of complexity on top of an already fragile system, I couldn't even imagine, all the edge cases that having that would entail. So that's really not an ideal path to take. So yeah, adding that complexity would certainly ensure the collapse of my already fragile system. So I did some more research. So Cinemachine had some sort of, I remember doing in my training, the Cinemachine had some sort of built-in fog effect. But I'm not going to move to Cinemachine just for that. I eventually discovered post-processing volumes, and there was a third-party fog package that uses them. So these volumes, they don't use Cinemachine, and what you can do is you can set them up to actually affect the actual look and feel of the camera rendering. So I purchased this on Thursday. I purchased this package because Unity doesn't have a post-processing fog effect out of the box. So this package actually allows me to do some nice distance fade effects with fog. So I bought this package and I set to work on a prototype scene to kind of again digest the functionality using the demo to see how I can apply this concept to like a prototype, and then eventually apply that prototype to my scene here. So after fixing some render pipeline settings, I was able to come up with this initial proposal and apply it to my test level scene. So I think this will work, but I was able to add this to my test scene. So basically, what happens here, if I can demonstrate what it actually does. So basically, I'm going to hide this. So basically when you're inside the scene, everything's fine. But when you go outside, this was previously working. When the camera moves outside, this area would remain lit. For some reason, this is not working out. It remains unlit, but basically you're going into a different volume. And now, yeah, so this is how it would look when you're in the volume. For some reason it's broken now. It would be lit. But when you go into the volume, naturally you'd have this fog effect applied. So it kind of dims everything out and you can't really see. The farther it is away, the less visible it becomes. So, and previously I had a plane here to kind of allow, when you're in the volume, to allow it to look like this, while at the same time having this outside area be all dimly lit. So that was working. As of now, it's not really working. But that being said, on Thursday, I think this is the right way to go. It does seem that'll work to solve this last case where it's like, you're going to the edge of the room and you can't really, you can kind of see the closest things here, but it's very dimly lit, and you're up here at a height, but you can't really see the back, all the room's far away. So that's kind of where I'm going with this. And so in doing this and applying the prototype to this test level, I was kind of struggling to get it to work, because the actual settings of the volume in the prototype were not matching the settings of my level scene. I had a different set of lighting configurations. Like each light had an intensity that really didn't match up with my prototype. So I kind of had to struggle in order to actually get it to this state where the lighting or the volume settings would affect it in this way properly. So that kind of led me down a little bit of a rabbit hole. So I was testing out different lighting positions, like where to put these probe lights and their intensities, and in context of the actual global volume, because there's a lot of different adjustments you can do. So, and it really depends, like the two work together, the lighting and the volume. So you kind of have to get it right. So I was really diving into the concepts of lighting. I had a basic understanding of point lights and spotlights and directional lights and all that, but it's like, how do you properly light an interior environment to make it look good? And, what are the tools involved? So I was really diving in and increasing my understanding of lighting and post-processing. I was getting my hands dirty with these lighting concepts. So, figure out things like reflection probes. What is a reflection probe? And basically, it reflects light back to these metallic objects and kind of brightens them up. And things like the lighting probes, right? They allow you to set these things, and when you're moving in between scenes, you can actually see, okay, he's kind of lit up and he has like a shadow now. That's great. He's actually lit up, but when you move to a darker area, you can see that, you know, he's not as brightly lit, right? And I had one of these tools that kind of, instead of placing each one of these individually, it's kind of a tool that automatically allows you to generate these light probes for dynamic lighting. So understanding the concepts of the scene of how lighting, you know, and there's a performance thing. So there's a lot of performance considerations you have to understand. Like the scene looks good and the lighting looks good, but how is it affecting the performance, like the quality, like running on the FPS, like, you know, what's the frame per second and the impact of it? Because these things don't come cheap computationally, and understanding how to optimize for performance, like understanding how to use lighting to kind of save on performance by baking in lights, while also at the same time uh, doing settings to allow for dynamic lights, because the player is dynamic, he's moving around, and you want a shadow for, but also baking in lights, baking in the indirect. So you can see when I turn off all the lights, there's still some sort of baked in light map texture. So this is the first real time I'm working with these sort of concepts in depth and really testing out and understanding how to use lighting properly with post-processing. It's like kind of orchestrating a lot of components together to make it, you know, the scene visually appealing. So um, so next week's a lot more testing on these concepts, you know, more testing about these light probes and really really trying to nail down a solid system where I can actually kind of replicate that, and actually, because you have to understand these concepts really in order to start building full levels, and you have to get the lighting, your understanding of lighting and the actual volumes, and in order to apply that to multiple rooms in the scene and so on. If you don't have that understanding, or you don't have a performance model to build a level, it's not, you know, you're gonna have to, you know, things might not work and you're going to have to rework a lot of things if you don't have a good foundation to start from. So that's kind of the idea. Prototyping system to prototype, yeah. So at the end of the week, I came from just having a basic understanding of, you know, just use some point lights to light the scene, you know, just so you can get started. But now it's like we're moving into more advanced lighting concepts to really, you know, make the scene look good. So that's kind of what I've done for the week, and more on next time. Thanks for joining us. So we'll see you later.